Good.
I'm not the only one who didn't go to bed.
Everybody sees.
I mean, I did too a little bit.
Good morning, Kiara and Malta. We'll be busy for a while, so you guys at home can do what you need to do for a while. Just stay tuned. We're going to do corona test. These guys got to clean their lockers like we did last week. And then we need to vote on Shula Honorasismus that you did last week. Then we'll start later on with reviewing circuits, okay? And that you can do with us, reviewing types of circuits and circuit diagrams and stuff about basic electricity. Okay? Nice to have you both, Malta and Kiara. I'll write you down right now. Hey, Tim. Good morning. I know, well, you're not alone there, but I'm supposed to check them out, so. Okay, what do we got here? 7 plus 7 is 20. Yeah. If you forgot it, we'll get it for you. You can get it down from Miss Hale. So, not to worry, all right? We'll get it worked out. Good morning, Timothy. So I'm writing my folks down. Try that. Yeah. Malta. And I got Amelie. Good morning, Amelie. You found all the parts there. That's it. Did you get one of these things too? You did the last one? I'll get some more. There's some more there. Thank you. I got a Lauren as well. Hi, Lauren. Good morning. Now, once you guys miss all this someday, you don't have to do this twice a week, Like I said, if I knew a year ago I'd be watching students put sticks up their nose twice a week, I wouldn't have believed it. If it's any consolation, I got to do it twice a week too. So, there's Lynn. Good morning. That's all right. Go ahead and get your goodies. Start up.
Oh, now it's like a.
I know it sounds like a Halloween tree, right?
Yeah.
Who else I got? I got Allie. Good. Good morning, Allie.
This is all we need, right? These two.
I think you need 4 things. Did you get one of these guys?
Oh. I didn't see that.
Good morning, Linus. So, folks at home, we're doing here in the classroom corona testing. Then we need to have them clean their lockers and do the,
Oh, shoot, I forgot my locker password.
do the Schule ohne Rassismus voting, just like all of you did last week. So hold on to your hats, okay? Do what you need to do for a little bit. Then we're gonna do some stuff with you and everybody, and that's gonna be reviewing electricity and circuits. If you didn't have electricity and circuits, I'll answer any of your questions as we go along, okay? But I had a feeling a lot of people needed some review here. As soon as you get your negative, just come up and show me. We're gonna throw everything away in the gray bucket. There it is. You got it? You got it. Thank you very much.
Bless you. We can use this to like write to the secretary to get that.
You can go to it right now if you need that.
No, not right. I'll do it like after school. Because I want to have the test, because like you can go on the store and stuff.
No, you
Exactly.
can't use this in the
Can you
store.
do that through the school? If you can, then you probably gotta go.
The
Did they
problem
tell you
you have
when
to
to go to the
go.
secretary to do that?
Somebody, like, you know Philip Wagner?
Yeah.
Yeah, he said he goes after school and he goes to the secretary.
Okay, all right, okay. So Adam, hold on.
You just threw it in the garbage.
Negative.
Werde negativ,
Okay, that, negative.
weil positiv
We're doing attendance all up.
I know, isn't it crazy? Thank you very much there. You're all set. Ingrid, and thank you. Good, the negatives are coming in, and I got another one. Thank you very much. And I got another person at home. Good morning, Charlotte. Thanks for joining us, folks. Folks at home.
I mean,
You know.
like, what's the benefit? Yeah, it's an eternity. I love how you know the pro. You know what? Tell us something. Tell us something. You know, like, it's my teacher, like, she got pregnant and then she missed the entire year. So. There's some teachers who still. When she worked for.
I got 7.
Okay, Miss Julius.
Oh, yeah.
No, Michael. Okay, I tell you what, as we're waiting for the last few folks to finish up, let's just review a little bit. So, open up your physics brain. Here we go. All right. I want an electromagnetic effect. I need a voice too. I want an electromagnetic effect. Give me one of 3 things that would be part of that. An electromagnetic effect. I need 3 things. Give me one thing, Zach. I need electric current. Give me another, Lesia.
A magnetic field.
Good. Give me the 3rd thing. Liam? Yain, we need to do something with them. Yeah, okay. Or another thing, a way to say it is I need what? I ended up with a force, really, Corey? So I need to do what to get that force? Yeah, movement. So I got to move that charge, the electrons, in the magnetic field. Good. What's the name of that force? It's got a special name for the German fellow that studied that years ago. The force. Probably is in your notes. You can just take a look. So, open up your notes. 2 people have it, so I know you guys have it. Ooh, the force, and one more, Liam. Lorentz force. Thank you very much. Good. Good. Give me an application of the Lorentz force at airports. An application of the Lorentz force at airports. Ever.
The X-ray machine.
Not the X-ray machine, that's where your luggage goes. I bet you mean something else. Yeah. Metal detector.
Yeah, oh.
Yeah. And as you walk through there, how does it work in your own words? How about Natalie?
Fingers, that means my sister. Anyways.
Think about it.
When you, walk through there's like, the metal detector has magnets in it.
Magnetic field, all
Yeah,
right?
magnetic field, so when you walk through, the electrons are pulled towards the metal on your body and it gets off and on, like it disrupts the, magnetic force of the metal detector.
Yeah. Back up once. So the knife, what do you got in your knife? What happens within like the knife or pistol or whatever,
It
Tim?
has an own magnetic field.
Yeah, good. The electrons move and create their own little magnetic field, once they do that. Yeah, and then it disrupts the other. Lorentz force, exactly. Thank you, Kiara. Thank you, Malta. These guys at home had it too. I love it. And yes, Alessia, absolutely you may. Yeah, that's fine.
Did you say if you move slow enough, they couldn't detect it?
Exactly. So if you move really slow, but like I said, Abram, if you do it, you're probably going to be detained for many hours. So don't do it. Okay. Yeah. Let's see. Did we do that? We did that one too. In the street. What's another application of the Lorentz force? Under the city streets at times. How about Jake? Under the city streets, pretty sure we had it, Corey?
Like stores.
Yeah, that could have there too, but that's the same thing. But no, I mean out on the city streets themselves. Do you remember, Liam, what that was?
It's like under the road, like
Yeah.
at the lights, they have plates so you can tell if there's a car there or not, so then they know if to turn on the lights or not, like make it go green.
Yeah, exactly. So essentially, what do they make underground? Let's see. Yeah, and Kiara, I bet you have the same idea for the stuff under the streets as well. Yeah, that's exactly right. Yeah, she has the one. Yeah. Good. Okay, so Kiara's reminded us that it's called a smart light, and that kind of like Liam said, the road, it detects the cars on the road because underneath the asphalt is a field, magnetic field, right? And then a car disrupts that, doesn't it? And then that tells the light to change. Boom, oh, become green. Here's a car waiting for you. Good. Yeah. Another really practical use of this force is a way we get electricity. So give me a way we can get electricity. How about Corey? What could I do? We did a number of ways in class. What's a way I can get electricity using the Lorentz force? Generator, can you describe kind of how it looked? Movement, continue. What did we move, Corey? Yeah, you can use it, you can move a magnet through a coil. There's one way, good. Another way to say it, Adam, what else could we do?
Probably you can move the compass with the motor effect.
That's a motor effect. We'll come back to that. That's the generator effect first, okay? So Corey says we can move a magnet through a compass. How else can we get electricity? Jake? How else can we get electricity? I had like 3 or 4 ways up front here. I know it wasn't right where you can see it, but just try and remember. Or you can look on the pictures. Oh, look, you got pictures I gave you. Oh, that might be helpful. So what's another way? We got only one way from Abram. Another way to get electricity generated. What could I do? Liam?
You could like have the coil spinning in the middle and then a magnet on the outside of it.
Yeah, and do what with the coil?
And spin the coil.
Ah, okay, everybody look at picture number 3, station 3. So Liam's described a generator which we had with our hands, and we made a coil spin in a magnetic field, and lo and behold, that made electricity as well. Huge. Good. Okay, back to Abram. What's the motor effect? When did we do that, Abram?
Last week, but when we do it, it's the power source.
Power source?
And then I forgot what the wire was called.
The lead,
Lead
yep,
and the compass and the current changes the compass. It's like,
super. So the current, when I turn it on, moves the compass needle. And that was called the motor effect. Yeah, good. So I can use the Lorentz force to move something, a motor, or to make electricity. That's the generator. Those are the two parts of this course boop, boop, that are really important for you. Let's see if I got any other comments at home. Yeah, exactly. Yeah. Kiara says we got a magnet or coil in a magnetic field with enough movement. That's exactly right to make electricity and generate. Thank you very much. Good. Let's do our next goal. Do I have everybody's negative? I got one more coming. Alessia's got a negative. Come on up and show me.
Minutes, right?
I think it has. Yeah. That's pretty negative. Thank you very much, ma'am. You can pitch it. And the gray bucket there is fine. And Liam is also negative. Thank you, Liam. Stella, I got yours now. I do. Thank you. And Tim, thank you. A completely negative group of students. I love it.
what
That's just
happens
the
if you
best.
mix all of them together and then press it?
You'd have a super negative, I suppose.
What if it creates a positive?
I don't think it works like electricity. Yeah, okay. Good. All right. So thank you for doing that. You're all set for at least a couple days till Thursday will be your next one. Let's go and clean out our lockers. So if you don't know your common name, here's why we're doing that. I know it's early, but I don't see you so much. You have 2 weeks of practicum, plus there's another week next week when I don't know if I see you at all. Yeah, I do. I see you one day Tuesday, but then the rest of the week is okay. Oral abitur, so you're not in school at all. Alessia?
But not just be like the next few days.
Yeah, that's right. So I won't see you anyway. That's right. I'll see the other half on Tuesday. Then the following week, I think I'll see you again. We have one more week before your practicum, something like that. And then you're in practicum side. So anyway, today we're going to go to our lockers, clean them out as best you can, get all the junk out, papers and whatnot. If you forgot your combination, you'll need it anyway because you're going to have to eventually turn in your lock probably in, let's say, 2 weeks. So I guess what I'm saying is, if you don't know your combination, go to Ms. Hale. Everybody else, let's go out to the lockers, trying to clean them out a bit, maybe show me, oh, this looks pretty good, all right? Other stuff right here. Thank you, Michael. Gotcha, Michael. Good. Any other folks? Okay, good. Yeah,
Do you have to just make sure that it's empty, or do we like have to clean it?
no, we just want to kind of empty it out, so they're more or less ready for next year.
We have to take this stuff out. Okay, you.
You can leave some books and stuff, but I mean, like, it's mainly get rid of all the garbage. Because when we waited some years to sell it all at once, then it was a big mess and we were full of paper and so take everything home that you can take home and then leave your books and stuff to give back to teachers. Yes, you may, yeah.
All that I got in my locker was a plastic bag.
That's not much.
Indeed, that's nothing.
Oh, wow.
I'm pretty sure half of the people don't know where their locker is. They're just like opening random ones and never in the vicinity of what they remember.
That's the result of our Corona year, huh?
Well, yeah, it's the advice we give you for rock.
No, not yet.
That's what I-
You're about 2 weeks early, Abram. You can put it back. I'm not ready for your locks yet, but probably next time I see you.
Can we take a picture of our, like, wait, I can just put this in my.
Either way, there or take a picture of it, whatever you wish. That would be fine, as long as you don't forget it.
I just sat there watching.
Thanks, everybody, for doing that. Appreciate it. I just need Alessia, then we'll start up here.
Let's see what to like I said,
Shared issues with the locker?
Let's see what, where?
Or something?
Okay. Well, I'll tell you what, let's start the next thing and then, she can join us at will. Liam, I don't know if you'd like to talk about this. This was something that student council kind of got going, or the Shula owner with business.
I think Alessia was onto that.
More on that, then I'll have a list to
What
do.
about your my law 15?
Shoot, thank you. With the lock, I don't need
Okay.
that, so, maybe, you know, like, I want to put it on the minute, let's see. But we've already, I need your help with this, I think, first. So, as people are voting, you can go and put that.
Oh, okay.
Alright, okay, so, Alessia, I'm gonna ask your help with this, I did the other portion of yours, I maybe, you wanna talk about this, a little bit of reading in English, the choices, talk about the voting a little bit, and then I'll distribute these once you, as you're doing that. Okay. So this is about the voting, so
Yeah.
I'll pass on, okay, go ahead.
So basically, as you know, our school is setting up a Una Justice Schools. That means that we are a school that is against racism and defends it. And to give the Una Justice Schools, you have to vote, get a certain percentage of vote, to become a Una Justice Schools. And all our votes have to be anonymous, which means if you do not know who voted for one, every vote counts. So basically what is that I'm committed to ensuring that my school has annual projects, campaigns that advance address and overcome discrimination, in particular racism. If there are violent discriminatory statements or actions taken at my school, then I will oppose them. Keep my mind toward an open discussion so that we can work together and find ways to treat each other with respect. And then that, we are active in ensuring that our school creates projects every year which work against all forms of discrimination, especially racism. So you can either vote that I want my school to join school net racism. You can either vote yes or no.
Okay, Zach, question?
What are these projects? Like if I say yes to this, will I have to be part of this project every year? Or what is it?
Not really any particular project, but I mean, I think as things come up, Zach, that we agree to work it out as a group. Am I
Yeah.
understanding it right, Alessia?
Yeah. But it won't be like you're given like every single month you're given projects that you have for a whole school thing. It's a community thing that we do. Like for example, we might hold events at school to address racism, or hold a fundraiser, or do some talks in class about the severity of racism.
Like, if you guys were here, I think last year, 2 years ago, we did that workshop. It was like the feminism workshop or something, equality workshop, and, which is, but anyway, basically,
Might be something similar to that.
yeah, so it might be something similar to that, so it might be like we have someone, a speaker comes in and talks to us about, the racist.
Good. All right, folks, once you vote, can you put it upside down then on your desk, and I'll come and collect them. I gotta put them in this envelope, and then I'll give them to, Ms. Gerhard, who's counting up all the votes. So just upside down when you're done, and then I can slide them in, and I don't have to then. Thank you very much. That's fine, take it, let's do it. Okay, so. Whew, all right, folks at home, folks here, we're ready to actually start with some physics. So let's go ahead and begin. I'm gonna raise this so I have a little room here that folks can see easier at home. And here's why I'm doing this. I felt like at the beginning of this electromagnetic unit, actually you did almost better with magnetism than electricity. And I thought, you know what, let's review some electricity because this is a really important basic concept in physics. Okay, so the three components of electricity and sort of their meanings. What I mean is this, okay, electricity has three big ideas, kind of like electromagnetism did, but now it's so one step before. So electricity, it's got a hoo-hoo, and a hoo-hoo. So, Jay, can you start us off? Give me one of the qualities or things you know about electricity. Yeah, okay. And that's sort of what it is in a general way, but like electricity has a certain hoo-hoo, or a certain hoo-hoo, or a certain hoo-hoo-hoo. Are there any of the three things you can tell me about the like quantities, measurable? Current, good. Okay, so let's start with that from Jay. So current, and it really is like a number, like we measured in, well, we'll come back to what, so it's the amount of food that are flowing. Jake sort of said it already, amount of food, maybe folks at home can help too, that are flowing, well, in a lead or in a wire. Okay, Michael had current. Thank you, Michael. Let's see if we can maybe fill in the blank. Let me read it, folks at home. So current, yes, the amount of fluid that are flowing in the lead. And I bet some will have it at home, and Michael does, and I'll come back and get it from Tim too. Electrons, and so does Michael have that. Good. Huge. Number two. So not only can electricity have a current, it can have another quality. Quality, Alessia? Voltage. And this I find is a little more challenging for students. Linus knew that too, as did Charlotte and Kiara. Thank you so much. Good participation, folks at home. Appreciate it. Right, okay, so voltage is the drop of the flowing electrons. So voltage is really the drop of flowing electrons. Correct. No, not really speed. Not really speed. Drop, Alessia.
Power,
Close.
what?
No, not power. Yeah, energy. Energy. Yeah. Let's see if folks at home had that idea as well. Yeah, good. And another way to think of it from Michael, it's the pushing power. I like that. So how much the electrons are pushed. Pushing power. You know, a lot of you had potential energy, and I think you all agree when you study this or 7th or 8th grade, right? Like if I have this, it's got a certain amount of potential energy because I can drop it. And if I want that to be more, I can just do what with this, Stella? I can do what with it, Ingrid?
Do one momentum by like pushing it down.
Then I'm adding another sort of energy. I want to give it more potential energy, something simple. Put it up higher. Okay, so now it's got more potential energy. That's the same way with electrons. I'm not pulling electrons and holding them off the floor, but if I have more energy, sorry, not more, if they have more change in energy, they have more voltage. Think of something going from like -1 to +1. Not think of an electron going from -20 to +20. You know what I mean? That's going to push them more, as Michael said. So more pushing power, and it also means if they're going from more negative to more positive, they have a bigger voltage. So that's kind of what voltage is like. Like, am I being pulled as an electron a little bit? Or am I being pulled really severely? And there's a lot more voltage pushing or pulling me. Okay? Good. I think a couple of you had the third thing too. So let me take a look. Yeah, Kiara had it, as did Michael. And the third thing, let's see if somebody has it here. Current, voltage, and the third thing. Got one guess here. Anybody else? Alessia, what is it?
Power?
No, power is the energy per time. So that's like, it's derived from these, but it's not one of the three basics. It's important, but it's not a basic. Okay, from Kiara and Michael, let's give it to them. It's resistance.
Oh, I thought that was for objects, not for electricity.
It's for electricity also. They can also have resistance. Now I know there's a certain resistance when I push things over something, right? And that resistance we can also say starts with an F. When I push something over something else, it would be in the friction. So I got resistance. And it's really similar with electrons. So this time they've got resistance, Ingrid, as they're doing what?
Moving across each other, I guess, like passing each other.
Well, they're not passing each other. We got like two different wires if you're thinking about the power company. They're not passing each other. What are they going through? The electrons are not alone in the wire. What else is in the wire? Well, what's it made of? What's in the wire, Tim?
Copper.
Copper. So copper are in the wire. Copper what? Something easy. Atoms, exactly. Atoms. So they got to go through this. So as they go through there, there's also friction. Okay. So resistance. Bless you.
Isn't resistance measured in ohms?
It is. We're going to come back to that. Thank you. So resistance. The friction that electrons feel as they flow in a lead or wire. The friction that electrons feel as they flow in a lead or wire. Good. How much resistance is there if they're not moving? It's kind of a weird question. What if electrons are not moving? Clara, how much resistance might there be?
None.
None, exactly. And it's the same with you if you think about it. If I try and move my leg, okay, I feel some resistance with the floor, but if I'm not moving it yet, then there's no resistance yet. There's no friction yet. Kind of weird, huh? So friction goes against movement, but if there's no movement, there's no friction. If there's no flowing electrons, there's no resistance, as it turns out. Zach, comment or question? No. No? Okay. All right, so let's make a little chart. Unless we got questions from at home on those three items. Those are three important basics in electricity. Okay, so then I'll erase them because I need that spot so folks can see them there. Oh. All right, so we're going to call it item label. Is that what I want to say? Maybe that's what I want to say. Okay, so my three headings, folks at home, if you can't see my blue, item, label, and symbol. So let's do the first one. So first one is current. Symbol. I got one more, dog. Okay, variable. Is that right? Yeah, that's kind of it. Okay, so what do we label current in? It's in, like, I got up like 20 what? 20 of what sort of label for current? Remember, Evan?
What?
Watts of new power. That's not current. 20 what? Yeah.
Yeah.
Amps. Yeah, amperes. Okay, and here it's very blurry at home, so I'll read it. Item, label, symbol, and variable. So label is amperes. And the symbol is just what? I don't have to write the full word ampere. I can just write what. That.
Is it A?
Actually, it's even shorter, Zach. A. Capital A, I can just write that for the number of amperes. The variable. Hint, think of the power equation. What's the letter we use for current as a physics variable, like X in math class? What's the letter we use? Two people remember? Let's see if somebody at home remembers too. The variable, folks at home, we use for current is what letter? What letter? Oh, good. C, no. C is not used because it's used for current, or for current. It's used for Celsius and a lot of other stuff in physics. So they don't use C. You had it in the power equation, folks. So actually, I should have more of you with your hands up. Let's see if some folks at home have it. Yep, we do. We got it from Malta and Kiara. Anybody else here got a guess? Liam?
Okay.
No. Actually, you shouldn't have to guess. It's what, bro? No. P. It's I. Remember P equals IV? Power? We had that just like last week. The paper equation. That's what I mean. That's what it's a variable is. And again, they don't use A, they don't use C because they're used for lots of other stuff in physics. Okay, let's go to the next one. Next item, of course, is voltage from our previous discussion. And this one's a lot more straightforward. So what is it? The next one, Stella, the label is, it would be like 220 what? Here in Europe. 220 what? Pigs, mongoose, piece of paper, no, 220 what? It's voltage, don't make it hard. Volt. In Europe, you use 220 volts. That's your power supply. All of them use that. Okay. The symbol. So what's the variable symbol? Jim? It's V. So that one's a lot more straightforward. V for volts. And what's the variable? What's the variable? It's probably J what? Also B. We'll do the last one after you take a break. Folks at home will continue in a few minutes. Thank you, Kiara, Malta. You guys got it? That's right. We'll do the last one together. Okay, see you in a couple minutes. Let me go deliver this as I'm supposed to. I did it delivered.
At lunch?
Yeah.
How long you?
wanna go back to first?
Yeah.
Alright. Do you see what I have in my lunchbox? Pasta. The weirdest snack I've ever seen. Actually.
Are you going anywhere for the summer?
I plan on staying here. My parents want to go to America after they get vaccinated, and I'm like, nope.
Wait, so who would you stay with?
Myself.
Wait, all of them.
Yeah.
Um,
Maybe I stay with my friend.
I'm going to stay.
Alright. Let's practice our sugar. Should I just start?
This is, artistic research, then I don't know what. Mark.
You kind of read that.
Ready for English essay?
The first time
The English essay is really good.
I.
Wait, we're running class. Are we reading English essay class? I hope so. Alright, ready, Leslie?
You can't see it. So we have the goodness of my heart. I posted, I made them bigger, on the other, like on other slides, and then I can see that was a slideshow.
Okay.
I'm like,
Ready?
I literally made, like, and then it's like combined.
You wanted to see me?
It's like active, but.
Yes, come in, my chair.
Thanks,
Would you like something? We'll coffee, tea, lemonade.
no, thank you.
I have my sister in store getting something. I hardly had things truck and he's fast.
No, I just wanted to talk about these email messages you sent. They're a bit odd.
I was just like.
No, that's good. You're right, no, that's all right. I want the email messages are.
Oh.
No.
Well, that's all right. I wanted to say your email messages are a bit.
I would just say that.
Well, you sent this one about 5 minutes ago. Thinking of you, and that's it.
Uh-huh.
You sent these messages to the other employees.
That make you jealous?
Well,
I sent that message to everyone who works here. I think of all my employees. Would you rather just put you out of mind?
well,
I can't do that. I think about you. I'm sorry. Yes, you have that I didn't.
you sent me this other one at midnight last night. Where? Hey, answer tomorrow?
New dress code.
I don't think that's appropriate.
You don't know to get the perfect Twitter chaos.
No, for you to tell me what pants to wear.
I'm just trying to reach, trying to push you to reach your potential.
My potential has nothing to do with the tightness of my pants.
Let me be the judge of that. Sorry, that's a joke. You need to lighten up. You're so furious all the time.
I don't know what to say. I'm just trying to figure out.
I am the leader of the kids, okay? That's why I'm in the bus. I am you. You are responsible for operating the it has sorry. It's done here. Don't get on your feet. Neither of you might have a key already. So shit. Have some more. Well, then German. Something fun.
didn't let me say.
Oh, sorry, I thought you were practicing on your own, sorry.
I am Jim.
Captain of Joy?
It needs some work. General work, something fun. You know what we should do? We should go out to dinner and talk about things.
What? I have work to do.
I've got some important, well, I'm really busy right now.
I'm really busy right now.
Sure, but what if I said, don't worry about that, let's go to our dinner set. How would that sound?
Look, I've got some important clients that have to
No, I gotta leave.
Are they more important than your class? Are they?
I gotta leave. I can't do
You know you're tired of me, right? Dinner with me first, slide second.
Should we be having dinner?
Yes? Do you think we should be having dinner together?
You think we should be having dinner together?
Yes.
Okay. And then,
It's just romantic.
is this a romantic thing? And then you're like,
It's romantic, and then I'm like, my monologue.
are you doing your whole monologue?
Yeah, so that's
You can cut
I cut two parts off.
They can hear this one.
This whole script, yeah, I know. This whole script is literally like taken straight from like Mangrove. This wasn't even a written script. They had some weird ass script, bro.
How do you even know what Mangrove is?
I have pictures. Have you never been on the
Have you never been in a big taxi?
Hey, if you guys watch Eurovision on Saturday,
I don't even know. I'll get all
Bro, this shit's delicious.
Yeah.
Cheese was fucking
well,
delicious.
first of
Yeah,
cheese was not even fucking vegan.
incredible. I mean,
I'm not vegan, I'm
the
vegetarian.
way the technique works, and also it was something a bit different, because if you look at a lot of the songs, they all sound the same. It's like, sure, like, you only have few parts to go, but there's not gonna be something that sounds like something you hear every day.
Something's trying to drink.
I heard from like friends, I thought hers was the best, it was like a real French song.
Oh, yeah, they can do
And you
How do you look worse with the glasses on?
Okie dokie. The third one was,
Fabulous. Literally read that.
okay. All right, folks, and folks at home, I'm back as well. Super. And, okay. So, resistance. What's the label for resistance? Do we remember? One person may, Alessia?
Oh,
Ohms. Okay, the variable, not a variable, the symbol. Like it'd be like 100 what? How do I write a little symbol? How do I write the symbol? Yeah.
Is it O?
It's not O, it's the Greek version of O.
Oh.
Omega.
Oh my god. Oh my god.
Oh, however you say O in Greece, okay? So, omega. So remember the horseshoe? It looks a bit like a horseshoe. So when you see that, that's what that was back a year ago. And the variable, the letter we used in equations for Jake.
I have a question.
Yeah.
The variable for voltage, is that lowercase?
I think it's uppercase. The variable is like a capital B. Yeah. I think all three of these are capitals. Okay, let's see if somebody at home knows. So at home, what do you know? What's the variable? What's the letter for resistance? Good. How about R? Ute. Then let's get the main. Yeah, let's do that first. Let's do Ohm's law. So not only is Ohm honored, Carl Friedrich Ohm honored for his work on electricity, but he also came up with an important law. which said the greater the current, the greater the, and, well, let's fill that in first. Maybe somebody here or somebody at home knows. The greater the current, the greater the, you remember, Liam?
So I have a question about R.
Yeah, okay.
Is it the same R that's in like gas and like chemistry?
No.
Like the ratio, or is that a
No.
lowercase R?
No, unfortunately, capital R is used in chemistry as well. It's called the ideal gas constant, and it has nothing to do with resistance. So alas, we have two different meanings, Liam, for R. But usually either we're talking about gases or electricity. So here it's just gonna be R, it will be totally just electricity.
So we don't have to know that like number is 0.06, whatever.
You do not, you do not. No, and our number here will be given to you unless, well, yeah, for the most part. Okay, the greater the current, the greater the what? Let's see if somebody has a guess. Oh man, some of you have it already, which is super. You got the law in letters. I'm going to come back to Kiara and Michael in just a minute. Yeah.
Electricity or power?
Well, no, just go to up above. Voltage. The greater the current, the greater the voltage. Greater the current, greater the voltage. And then he also said the ratio of V to I is called the resistance. So, from Michael and Kiara, and let's see if someone else remembered it. Those are the main two. So you remember the equation from last year. Okay, anyone in my group's going to remember if I say twinkle, twinkle, little star? That doesn't help you. Okay, then you were in my section.
Ooh, was it in
Twinkle, twinkle, little star. Alessia?
Is it, like I equals
No.
B equals, and then I, and then O symbol?
Twinkle, twinkle, little star. B is equal to R.
IB over R?
Why you just right what I got?
Oh.
Now, remember the nursery. Don't make this hard. It's not, okay? Kiara and Michael had that already, okay? But just remember the nursery rhyme. I'm not kidding. Twinkle, twinkle, little star. V is equal to IR. And then you'll always remember it. See, there you go. There you go. Or, if some of you have this in math class, it's a cool way to get it with like a triangle. Have any of you used triangles from any of your teachers?
Yeah.
Okay, can you put that angle in a triangle? How would that look? Here, I'll make a little bruster for you. V's on top and
IR go on the bottom.
you got it. So here's how, if you haven't done this before, maybe you're in another section or another school, I don't know. So V is equal to IR. And then you can say, oh, for example, what's I? I is equal to V over R. So you just cover up what you want to solve for. What's R? R is equal to V divided by I. That's going to be pretty handy for you and I when we do what's called solving circuits. All right, so twinkle, twinkle, little star, V is equal to IR. That is the basis of a lot of electricity. Boop, boop, boop. Super important. Put a box around it. Have it tattooed in your heart, whatever you want to do. Yeah, that's very, 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 very important. Okay. 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 So, there we go. Um, I think we're good, unless you got questions. Otherwise, I'll propose. I want to go in two directions with you, both today and then the rest of the time that I see you. I want to go in this direction where we can do what's called solving a circuit. It involves mathematics. And I want to, at least up front, kind of have you help me build some circuits. Some of you built circuits last year, so I'm going to have you remember how to do some of that building as well. So building, solving mathematically, those are our two goals using Ohm's law and others. Okay, the other ones, I think we better wait till we get a circuit, otherwise it won't make any sense to you. So let's talk about circuit parts and symbols. I didn't bring it today because frankly my hands were full of Corona stuff, but I'll bring it with me tomorrow or whenever I see you this week again. Do I see you tomorrow? I see you tomorrow, right?
I think it's our last day.
Today?
Do we see each other on Thursday?
I get mixed up on 9F. We see each other tomorrow. That's it, tomorrow morning. Okay, well then tomorrow morning we'll practice both of those two things. We'll practice the circuits and solving it. Okay, circuit parts. Okay. I'll leave, I had so many of them on my card and I rolled my card back to physics. A lead is kind of like even a chord, right? So a chord could be more or less type of lead, like we used to make up all our demos with electromagnetic effects. So the symbol for that on a circuit diagram just look like what?
Just a line.
Thank you, man. So if it's a lead, it's just a line. What about a power source? A power source on a circuit diagram. Let's see if some of you can pull that off from last year. Yeah, thank you, Charlotte. Sorry, I don't always catch that quickly. I know it's hard to read. Okay, so power source is what symbol, or folks at home can describe it as well in a circuit. We're going to define these and then we're going to draw some circuits. I know you had it last year. This is why we're reviewing it though, so don't panic. Remember, Liam?
Oh, it's like a long line and then a short line.
Yeah. All right.
Parallel.
Remember that, everybody? Two lines next to each other. And we're almost done. What do we got to add to that? What do we got to add to what Liam was giving me? See if somebody at home knows. Then somebody out here, go ahead. No, not that company. Just what do I got to add on here to this to show it's a power source? You remember, Alessia? No? No. A long line represents the positive pole of the electricity. The short line represents the negative pole. So you got to put on a plus and a minus on your power source. Okay. Then generally we show a lead coming out of either side. Remember I had two leads plugged into my power source? That's what this is supposed to represent. So one's going out this way, the other's going out that way to wherever. Okay, good thing I asked that. So that's power source. Thank you, Kiara. She knew that plus and minus poles, right? Plus and minus, yeah, good. Consumer of power or light bulb, thing that should make a light bulb appear above your head. So what do we use for that symbol? Natalie remembers? You got it. So, right? Yeah. So that will represent either something like a toaster or whatever, or it could be a light bulb, anything that consumes electricity. So we got two different, we got two different, definitions of consumer, right? When you and I talked about power, we said there's a power company, then there's you and I, we're the consumer. Now we're also gonna think of the item as a consumer, a light bulb or whatever's consuming and using the electricity. Ute, okay, then, for folks that got that far last year, if I could spell it right. What's a resistor? Resistors are in lots and lots of your devices. I should have brought one, but again, I don't have one with me. They're in your handies, they're in your TVs, they're in your laptops, they're in your tablets, whatever you got. Lots and lots and lots and lots of resistors. They're even under the keyboard, boop, 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 where you type your messages.
Is it like
Yeah.
metric?
They actually like slow it down. Think of like a resistor being something like adding more friction. So the more friction, the less gets through. What would make sense? The more friction, the more resistance, the less gets through. Yeah, so we could say which thing? Current, you like less current gets through if there's more resistance. Makes sense, right? So if I had no desk between you and I'm going for the door and I'm an electron, I could just walk there, no resistance at all. But I got all these desks, I gotta go around these, I gotta get fixed, there's more resistance, more ohms of resistance. And so it would be harder for me to do that. Okay, the symbol for resistor. I wonder if Alessia will remember because we did have it last year. Kiara remembers, let's see if anybody else does at home. Remember what it looked like, Alessia? Just for grains? If you didn't, it's okay.
So I remember we were supposed to be tiny little resistors.
Yeah. Remember the little tiny ones?
Yeah, we had to basically find out the ohms that they
Yeah.
would tell us.
Good.
I don't remember.
Here's the symbol. Kiara says it's a squiggly line. She's right. Looks like that. Can you guess why physics chose that symbol for it? Based on what I've told you about resistance, correct?
Because it resists in some ways, so it's like it shows movement, but it's harder. I'm not sure how to explain it.
It's harder for the electron to what?
Move.
To move, to get through, right? So instead of going like this, the electron's got to go kind of like I talked about with the desk, right? Bump, 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 bump. Oh, there's more resistance of that electron to moving around. Yeah, good. They changed current like a squiggly line. Rectangle. Rectangle going to be something else, Lauren. We're coming back to the rectangle right now. Okay, let's erase this. Let's now put here voltmeter. Hey, we used the voltmeter this year, right? Remember the big giant one I had? Okay. Voltmeter, or for measuring current, it's called an ammeter. Seems like it ought to be amp meter, but it's not. It's ammeter. Okay, the symbol for those, remember? Yeah, go ahead. Just a V inside of A. Yeah. And of course, ammeter would be the same thing, except it's going to be A inside the circle for ammeter. So I've got a V or A inside of the circle, shows I've got a voltage measuring device. Yeah. Okay. Might be the last thing. Let's see. Last thing I can remember. Switch, or in German, what? Shout them. I remember doing right this morning. What's the symbol for a switch? Ah, a couple of you remember. Maybe somebody at home does too. The symbol for a switch. How's it looking? Okay? Leo.
Like you draw basically two dots and then one you draw a line going up,
Super.
or line going from the dot to the dot. And if the line is connecting between the dots and its switch is closed,
Yeah,
the line's open, then it's
you got it. So just open up, and you can have the dots, although I don't really care if you do or not, to be honest, but you gotta have it. Usually it's written as Liam said, opened up like this. Even though in reality, when I bring one in, you'll see we can close it as well. But that's sort of the deal. So the switch is like an alligator's mouth, right? To show it opening or closing. Let's see if some of those had that at home anyway. Yeah, Kiara had that. Yeah, line connected to dots. Yeah, that's right. That's right. Okay. Huge. Let's draw a couple circuits. Questions from you so far? Okay. All right. So here's an example. Draw a simple circuit with one consumer. Draw a simple circuit with one consumer. I know folks at home can't show it to me easily, so just go ahead and try and draw it in your notes at home. Okay, how about Jake? Start me off. What do I gotta have if I'm gonna have a consumer? All right, so I think I heard you say a power source, right? And also a consumer. So I'm gonna do that. Here's my consumer. Here's my power source. And I'm gonna put plus and minus because you actually have to do that. That's part of the drawing. And now what physics does is, this is maybe what Lauren was saying. So Lauren might have been referring to this as well. Generally, what they do in physics is you want to make what shape? What shape were your circuits last year in general when you're done with them? Remember, Zach? Not a circle, but like a box, like a rectangle. So often they end up showing you this like this. And that, my friends, is the simple circuit. And just some terminology. If I have a lead that's missing, then we say it's an open circuit, and it's not doing what? If it's open, Evan?
making energy go to the consumer.
Yeah, close. Making not the energy, but the what are the little guys moving?
Electrons.
Electrons. Okay, so yeah, so if it's an open circuit, that's not very good. It's not going to allow the electrons to move. So let's make it a closed circuit. That's how we say it. Oh, the circuit's closed. That means they can flow. Now, for grants, let's put a little arrow on this. So think of which pole are the electrons coming from, and which pole are they going to? Got a couple guesses already. Which pole they coming from, where they going to? Jay. Yeah, but which one are they coming from? Exactly. What's your source of electrons? Negative. Okay, so they're going from the negative to the, draw some arrows. I better draw with a better marker than that. So folks at home can see it. So Jake says negative to positive, so I'm going to just show that. Here they go. I'm coming all the way back to the positive side. Yeah. Huge. Questions so far from you? Yeah, and that's what Kiara said too, right? Come from the negative and go to the positive, right? A Rooney. Yeah. Okay, so your turn. Okay, folks at home and folks here, let's try and do this. So it's your turn. Try and draw a circuit with an open switch, with an ammeter and two consumers. Also show the current direction on your circuit. And you may begin when you get it written down. Folks at home, try it too. I know I can't see it, but give it a shot. I'll come around and see how you're doing. I can have somebody put it up on the board here in a sec too. Yeah, there has to be listed. If I got consumers. But when you get that far, I'm gonna ask you why it doesn't matter. Looking good, looking good. In that direction, if you don't know what it is. Yeah. With the negative positive nuance, you kind of have to have it coming in and out of there. So, like I go up, you can actually connect it. So go up into the little thing, open that through, come out inside. It's in the middle of the plus line. Yes, that is the direction. Yeah. Well, go, okay. Let's do it. Tim, got two.
You'll be able to- Just put it somewhere in your square. You know? Okay. Great. Dan, can you show your directions with green? Thank you. Your electron directions. Thanks very much, Dan. Okay, so folks at home, yeah, okay. Wish I could see yours, but I can't. Leslie, question?
Both the arrows have to be in the square.
Not
All
necessarily.
aligned. Okay.
Not necessarily. You can put it in there too, that'd be fine. But, either way is okay with me. All right, let's have a look. So let's do a little check. So we've got an open switch, that's here. We've got an ammeter, that's here. Two consumers here and here. And we're all in one circuit, and we need a power source. So important, you need to have the line coming out of the middle of the plus side and the middle of the minus side. That's just kind of traditional how everybody draws them. Good. Then either on the lead or next to it, like Corey did, put the direction coming from the negative and going eventually to the positive. Questions from all of you? If your diagram's not perfect, just change it a little bit. Folks at home, how many got that correct? Go ahead and raise your hand. Nice. Well done. Okay, good. I know, I wish I could see it, but I can't. Okay, just joking. All right, so let's try this. Let me just think. Oh, do I want this now? Yeah, I can do. Okay, let's do this basic. So, I was working on it. I really gotta like renew that thing, don't I? So the big thing you might remember from 8th grade is we have these two general types of circuits, and they're called series and parallel. So maybe that rings a bell now. I hope so. If not, we're gonna make it ring a bell. So I'm trying, folks at home, so I'll just sort of get you as close as I can. So the circuit diagram, now they can't see that very well. It's kind of glary, isn't it? My problem is I can't move you over because my power source is over there, and I don't have an extension cord. Tell you what, let me write it again real quick so you guys can check it. So here we do. So something like that will work, okay? So folks at home, if you had something, a little sloppy here. If you had something kind of looking like that, then you probably did it right, okay? I had to redraw that because they couldn't see it, folks here. Sorry about that. So that's what I'm trying to draw for them. Okay, series and parallel. Let's see if we remember. So a series circuit. Now that we've been doing this, is your brain starting to spark? You remember what a series circuit kind of looked like? Alien?
It's like one we just drew, so it's like it always it goes in a constant one, and then the difference is there's parallel. Parallel is like branches off into two different ones.
You got it. Super, Liam. So parallel has branches. Series is just one set of leads, one pathway. So it's one. I like the word one. I like my letters today. One pathway for the electrons. Okay, for example, shaboom, shaboom. Okay, plus, minus. Here they come. Oh, okay, let's say we go through 1, 2, 3, and 4. Consumers. It doesn't matter how many I do. So that would be a series circuit. It's only one pathway because the electrons don't have any choice. Boom, 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 boom. So frankly, all the circuits we've done so far have been series circuits. Now, I had a question or a comment earlier from Abram. Abram said back here, does it matter where you put the ammeter? And I said no, and now I'm going to ask Abram, if the ammeter measures the amount of electrons flowing, why does it not matter where I put it? Exactly, and they're flowing at the same what? What could we say? Speed or rate, okay? They're flowing at the same rate because I only got how many pathways? One. So if I got one pathway, it doesn't matter where I put the ammeter, the current's the same everywhere. And that's really an important point for series circuits. Current, whoops, sorry, I didn't write what I wanted to say. Current, same, everywhere. So if I got, I'm going to make something up here. If I got like 2 amps here, if I got 2 amps here, it'd be 2 amps here, it'd be 2 amps here, 2 amps here, 2 amps here, 2 amps here, 2 amps. Okay, everywhere. If I got a circuit that's closed, so to speak, it's the same current everywhere. Good. I hope that worked now. Okay. Good. Let's do the other one that Liam's described and see if someone else can tell me about the drawing. So we're going to now do a parallel. For parallel, so now there's not just one pathway. So even if you haven't had this before, what might change so to make it that I do not have one pathway? How can I change my drawing a bit? So aside from Liam, well, somebody else, let's see if you can figure it out. How would my pathway change? Jake, here's my electrons. They're coming out of the negative. And they're going here to the, oh, they're going away from the negative. Okay, how can I make it so they got more than one pathway? How can I change my drawing? Here, one pathway. The lead splits. Good way to say it. So watch this. Whoa, now I got 2 pathways. Can I make it split again? Yes. Whoa, now I got 3 pathways. Could I make it split again? Yes. I could. How many times could I split it? Whatever. Guess what? At home, it's split a whole lot of times in your apartment or your home, okay? Let's just have it split like 3 times. So let's make that come around. So then, let's put like, I don't know, let's put a consumer. There's your dishwasher. There's your outlet for your computer. There's your hairdryer. But now we gotta, what's gotta happen at the far end, you suppose? What, how do I gotta finish this, so to speak? Ingrid?
You have to bring them all back together. So you connect them.
Said that in a good way. Bring them back together. Okay, the rest of it, I don't really care about, it should come back to you. So that, folks, is a parallel circuit. Because in math class, I get what do I have from math class that kind of is the same thing here, Jake?
The streams are parallel.
They're parallel, right, the three streams of electrons are all parallel, or 4 or 5, or however many you want to draw, right? Question, Jake?
Parallel.
They're kind of always drawn that way, Jake, so in a sense, yeah. In the real world, that could be wired in your house, they're sort of next to each other. It doesn't have to be 100% parallel, but they gotta be separate pathways. Now, let's follow the electrons. Ready? Here they come. Ooh, but now they get to this. What are my electrons gonna do at this spot? Tim? Split. I can have some going still straight ahead and Tim some what?
Go down.
Next spot, Claire, what's gonna happen to my little electrons there? I'll show the way she just pointed. So some to the right and some down. And then these guys gotta keep going, right? What's gonna happen then back at the bottom? Think about what Ingrid said, they gotta get back together. What's gonna happen at the bottom? Can you describe that? Stella, what's gonna go on at the bottom? As our little thing goes along. Think of like a water analogy, right? It becomes water. What's going on? What happens right here? Hey, the ones from where and where? Explain in words. Coming down from the consumer and from the other one, from the right one. Okay? All right, so they join. And then down, and now over here, what's going to happen there, Albert?
One, the electrons are moving from vacuum down, and then keep going left.
Good.
Oh, and also, what did you have to put the ammeter past the consumers on this one, some editors?
All right, that's a really good question. Let's say I put a bunch of ammeters. I don't even know if I can fit them in. Let's do this. Let's say I'm gonna put a little, I'll put one here. Okay, I'll put one here. And let's say, let's let the current equal 9 amps, okay? So let's have it in this spot, once they're back together, like Abram suggested. So at this ammeter, let's say I got 9 amps. Let's say all these 3 items are the same over here. Here's my question. Yeah, you know what I'm gonna ask. What's gonna happen over these branches? Good, I got 3 hands already, and I bet I got some folks at home that can say this as well. Okay, go ahead, Ingrid.
I think they divided by 3 so that they each have an equal amount of like current and electrons going through.
Good.
But it doesn't like overload the yeah.
Yeah, so how many would be going, we're gonna call these pathways or branches. So in this case, if all 3 consumers are the same thing, how many will be again in each pathway? 3 amps, right? I don't really have room to put an ammeter, but if I could. Okay, let me point to a spot. What about right there? What would the current be right at that spot? Got one guess. That's all where I'm pointing. What would the current be at that spot? Maybe somebody at home can do it too. Yeah, exactly, Kiara, right? Good. What would be the current at that spot right there? Or,
Would be the highest,
yeah, what should be? Give me a number.
oh, right.
9 inch, right? Okay, here's a tricky one. What would be the current right there at that spot? Where? Yeah, good. Can you explain it?
There's the power of the.
Yeah, good. So the power or electricity from 2 consumers. So we got it. So that would be 6. When will it be 9 again? Where will it be 9 again? Continue, Claire.
After the third one.
Super. Question. Your houses, or Tim?
Why would you always just?
The electrons can kind of feel what's out there. And so they're like, okay, 3 spots. Okay, we're going to divide up like this. Yeah, that's kind of thanks, everybody at home. So I won't, Julius and everybody, I won't put a live stream posting, but just show up, okay? Because I don't want to do this every single day. So show up with me tomorrow, and I'll say goodbye until then. Thanks for joining me. Bye-bye.